Where are we? Let's see, we're on page 669, and we're going to start. We're in test number 5, section 7. Problem number 1. Problem number 1. If k is a positive integer divisible by 3, and if k is less than 60, what is the greatest possible value of k? So it's a positive integer it's positive, so it's greater than 0. It's divisible by 3, and it's less than 60. K is less than 60. 60 is divisible by 3, right? 3 times 20 is 60. So if I subtract 3 from 60, that will also be divisible by 60. So k is equal to 57, right? K can't be 60 because it's less than 60. And then the next one down is 57. And if you don't believe that 3 is divisible into 57, 3 goes into 57. 1 times 3, 27, goes into it 19 times. There you go. So the choice is C, 57. And if you haven't learned this already, the easiest way to figure out if a number is divisible by 57, add the digits. So 5 plus 7 is 12. 1 plus 2 is 3. So if when you add the digits, the sum you get is divisible by 3, then the original number is also divisible by 3. So you could actually have gone down the choices, but you don't want to waste too much time on the first problem. Problem 2. The letter H is symmetric with respect to two different lines as shown in the dotted lines in the figure above. Which of the following is symmetric with respect to at least two different lines? So when they talk about H, they're saying, like, if I draw an H, they draw this line of symmetry here. And that means if I were to flip H over this way, I get the same thing. If I were to flip it over this line, I get the same thing. It's like a mirror image on either side, right? This green line is a mirror image of this purple line. And the other way is true too. If I have H, this mauve part is the mirror image of this brown part along the horizontal axis. If I were to draw if this was the axis of the mirror image. So which of the other letters has it? So it should be a letter that looks the same, that could be kind of folded in half either vertically or horizontally. And if we look at all the choices, X is definitely the answer. Because if you have an X, and if you have a vertical line of symmetry, notice that the left-hand side is the mirror image of the right-hand side, or you could flip it over, right? They look the same. It almost looks like a reflection of the other side. And similarly, if you took it the other way, also you could flip it up and down, and they also has the mirror image. None of the other letters have that property. Next problem. Whoops. Invert colors. Okay, problem number 3. Bobby receives $2 for each chore he does during the week, plus a weekly allowance of $10. If Bobby receives no other money, which of the following expressions represents the total dollar amount Bobby receives for a week in which he does n chores? So if he does n chores, how much money is he going to get just from doing chores? He does n chores, and how much does he get per chore? Well, he gets $2 times 2. So this is how much he gets just from doing chores. 2n, or n times 2. And then how much is he going to get even if he does 0 chores? Well, he gets a $10 allowance no matter what. Far more than I ever got as a child. So, what is the formula? It's 2n plus 10 is the amount of money he gets. And that is choice D. Right? N is the number of chores. He gets $2 per chore, and he gets $10 no matter what, even if n is 0, even if he does no chores. Next problem, 4. The smallest squares in figure A and figure B are all equal in size. If the area in A is 26 square centimeters, what is the area of figure B? So let me see if I can draw these figures. So I'll use the line tool. So A looks like, let's see, they have a line there. So let me draw a rectangle. So the rectangle looks like that. Close enough. And then there's another rectangle that's like this. See, there's roughly half like that. It's like this. Another rectangle like this. Oh man, the drawing is the hardest part. Type with my shaky hands. Okay, almost there. I think you get the point. I'm trying my best. Gotta give me credit. Okay, so that's figure A, and then figure B looks like this. Let's see, you have horizontal line, and then a vertical line like that. And then, let's see, it has like that. Connect these two. And then, oh boy, this is so tiring. I have a line like that. And then it gets split roughly in half over there. And then this connects like that. That connects like that. And then I have a line like that. So what they're telling us is in figure A, whoops, I don't want to do that. Edit undo. What they're saying is figure A, each of these squares are the same size as each of these squares in figure B. And they also tell us that figure A is 26 square centimeters. So the area is 26 centimeters squared. So we want to figure out the area of B. We have to just figure out how big is each of these little tiles, right? So how many tiles are in A? Let's count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 13 tiles, and they're 26 centimeters cubed total, right? So if 13 times the area of a tile is equal to 26 centimeters, a tile divided both sides by 13 is 2 centimeters squared, right? Each tile is 2 centimeters squared. And how many tiles does B have? Well, 1, 2, 3, 4, 5, 6, 7, 8. It has 8. So its area is 8 times the number of tiles, or the area of the tiles. And we know what the area of the tiles are. It's 2 because it's the same as A. So area is equal to 8 times 2, which is equal to 16 centimeters squared, which is choice C. Next problem. More drawing for Sal. Oh boy, it's the drawing that really tires me. Okay, and I got to draw it pretty accurately because otherwise this is all about reading a graph. That's all right. So let me draw. Let me make the first one in. So Albert goes to like 300. That's 300, and then it's 150, which is roughly half of that. So it's like around 150, like that. And then the next guy is like a little over 200. So it's like 2/3. Like, I don't know. I'm just trying my best. Then the next guy gets to like 250. It'll be like there. And then the last guy, I'm drawing the white box, is pretty much the same number. Just like that. And then let me draw the other one and the other. So the other guy is 150. That. This guy gets to 250, which I said was roughly the same amount as these guys over here. 250. Next guy looks about the same. 250. It's about that. And this guy looks like that. All the work I'm doing now is just to redraw what you already have. And then this guy, it's like 350. It's like 300 or something, right? And if I were to draw, let me mark it off with some. So this is 300. This is 150. See those guys that are a little bit under 200 in between two. So this is like 200. This is 250. They're asking us, according to the graph above, which salesperson had the greatest increase in the number of units sold from 1988 to 1999? So the 1988 ones are the blue ones, and the 1999 are the red ones. So you're essentially saying who had the greatest increase going from the blue to the red, right? And this is Albert, this is Goldberg, Patel. Oh, it's nice, included an Indian guy. Smith, Wang. I look forward to when they have a con in the SAT. But anyway, all right. So who increased the most going from the blue year 1998 to 1999? This guy clearly decreased, right? He went from 300 to 150, so it's not him. This guy decreased. He went from something larger to something smaller, so it's not him. So who had the largest increase? Well, you could eyeball it, right? Where are the increases? This guy had, whoops. This guy increased this much compared to a small increase here and a small increase here. So the answer is G, or Goldberg, which is choice B. See you in the next video.